Hey guys, and welcome back to another Unreal Engine 4 tutorial. In today's video I'm going to be showing you how to make it so the enemies or the AI will not move when you are looking at them. So this is similar to a mechanic in Little Nightmares 2, and actually it was also in the latest Five Nights at Freddy's game as well. So we're going to be creating this, and basically let me hit play and show you what we're going to make. So you'll see this enemy here is behind a wall. We are looking at them, but they're not going to stop moving because obviously we wouldn't actually be able to see them because the wall is here. I've just made it slightly transparent so we can see them. But after I press 1, the wall will disappear, we can now see the enemy, and it has now stopped moving. Press 1, the wall's back, they will continue moving as we can't see them. So what this is going to do is it will not travel through walls, it will only be able to affect enemies that you can actually see. So if we go over to 1, which should be here, there you go, we can see him, so he stopped moving. If I have to look away, he'll move again. Let me try, it's hard to actually show you while looking at him, but if I had to just look away, you'll know that he's moved about, because when I look back, he'll be in a different place, and he's not close enough yet. However, now he is close enough, he is in our sight of range, so we can see him, so he stops moving. And you can increase and decrease the sight of range, so it works further away, or you have to be a lot closer. So again, he's all over there. As I keep moving forward, this is where we can now see him, so he'll stop moving. And again, doesn't go through walls, as you can see here. So this is what we're going to be going over and creating today, so without further ado, let me delete this code, and I'll show you how I've done it. Now I actually tried about 5 different methods of me just going through different ways of trying to do this, and I found that this one I'm going to do, it seemed to be the most efficient and also gave the best results. So I tried different ways of line traces, sphere traces, capsule traces, overlaps, and all these different things. And the main aspect I was trying to get to work properly was going through walls. So what I've got here seems to be the best way that I found to manage to do it. So the first thing we want to do is, for the efficiency of it, we want to create a blueprint interface. So we're going to right click, go to blueprints, and then just create a blueprint interface. I'm going to name this one movement interface, as that makes the most sense for me because I'm going to be toggling on and off the enemy or AI movement, but you can name it whatever you want. And we're going to open this up straight away. Now, blueprint interfaces are read-only blueprints, and if you haven't used them before, you can watch my other videos where I do go over and explain them in a lot more detail to hopefully help you understand. But I'm going to go ahead with it now. So this function I'm going to name toggle movement, as again, that makes the most sense to me. I'm also going to add an input on here called isSeen. As again, that makes sense for me. So when this boolean of isSeen is true, we want to disable the movement. When it's false, I want to enable the movement. So you can also just name this canMove if that makes more sense for you. But for me, because this mechanic in which I'm doing it in is if they have been seen, this makes more sense. So I'm going to compile and save and close that, as again it's read only. That's all we need to do. We're going to access that later on. And one of those later ons where we're accessing it in is going to be now. So what we're going to do is open up our AI blueprint, which for me is just AI BP, and I've just duplicated the third person character in order to get this. So open this up, and in here, you can ignore that, that's just because I deleted the code earlier. So in here, all I've got is just some random Rome code, and that's it. So again, they're just going to be moving about the level. Again, I do have videos going with that if you'd like it. But all we need to do in here is go to class settings up at the top. Under interfaces, we have no interfaces, so we want to add one. Press add, and we're going to search for the one we just made. I named mine movement interface. We compile and save that, and you can see on the left here, we have an interfaces tab with our toggle movement function, which we created. So we're going to right click on our function, implement the function, and you can see we also have the input which we created of isSeen here. So all I'm going to do is simply hold down B, left click to get a branch, as we want to check to see if this boolean is true or false. If it's true, like I said, we want to disable the movement, and false, we want to re-enable it. So we're going to get a reference to our character movement here, drag out of it, and simply disable the movement, or disable movement it's called, and again, that's going to go into true of this branch, so if the enemy has been seen, they can't move. Now out of false, we're going to re-enable the movement. However, you'll notice that you can't just do disable movement and enable movement. That's not a thing. What you need to do is set movement mode. And we're going to be setting the movement mode, again, off of false and setting it to walking. And that is basically how you enable movement, is you just set the movement mode to walking or flying, swimming, whatever it is you want them to do. So if this is maybe a fish AI, you just set them to be swimming. But I don't know why you'd want an AI that can't move underwater, but obviously you do what makes sense for you and works the best for your AI. And this is also all we need to do in the AI blueprint. It's very, very simple and basic to do. because again, we're going to be communicating with this via the interface through our player blueprint for when we actually see them, because we want to know if the player has seen the AI, not the AI has seen the player. So we're going to close this, and now we're going to open up our player blueprint. And that for me is content, third person BP, blueprints, third person character, but for you this could be third, first, or whatever you've named it. Now if you're doing it in the third person character like I am, what I'd recommend doing is if you go to the viewport, you can see I've added in the first person camera instead. So I've just moved the camera from third to first person. If you want a video tutorial on how I've done that, I have also created one, which again I'll leave a link to in the description down below. And there's also something else we want to do in the viewport here, is let's select our camera, add a component just so the component is parented to the camera, and we're going to add a cone. Now this cone is going to be acting as our vision, so where the player can actually see. And now also one thing you'll notice is with this cone, the center of the object, so the rotation, the scale point, isn't where we want it. So it's going to be in this kind of off center there. Not sure why it is there, but that's not where we want it, because you'll notice that if I were to just rotate it like this, when we scale it, it's going to be scaling from there. Now how the system works is it's going to be scaling based on how close it is to the wall. So if I just close this, I'll show you. Essentially, as we get closer to the wall, the cone will scale down to make sure it doesn't go through. So we want to make sure it does scale uniformly. So this one doesn't. So what we want to do is select the static mesh, change it from cone to be our own cone which we have made. Now I named mine sight cone, I believe. Yep, there it is. And you'll see that now the rotation and scale point, or the axis point I think it's called, I forgot the actual name, but you'll see it's at the end there. So now when we scale it, it's going to scale perfectly like that. And that is what we want. So I'm going to rotate this to be facing the correct direction. If I were to do this, and I'll also tell you how to get this cone in a second. But I'm going to rotate it so it's like that now. So it's facing the correct direction. We'll compile and save that. So now what I've done is all I did was simply go into Blender, and I can actually do this with you right now, is go into Blender. You should have nothing here or the cube, but just delete all that. Press Shift A, go to Mesh, create a cone, press N to get this tab here for the transform, change the dimensions to be 1 meter, as that is the size of the cone by default in Unreal, and we want to be keeping with those scales. Then we want to just press R, press X, type 180 to rotate it to face up like this. Then press 1 on the numpad to get this view, press G, press Z, and just move it up until you get it perfectly on the red line like this, and you want to zoom all the way in to get the really close details like this. So sorry if that was a bit of a speed run through this, but I don't want to have this too much on how to create the cone, because it's very, very basic. We don't need to actually create any modeling, we just need to recenter it to be the correct point, and you can do that in Unreal, but for me it's just more efficient and easier for me to do it in Blender here, then export it as an FBX and just drag that in to Unreal. Here, as you can see, I've got this one here, sight cone, like so. So again, once you've done that, import it and put this onto the camera of the player like this. Then we're going to go over to the event graph, and we want to right click on our cone, add event, and add on begin overlap, or add on component begin overlap. So again, when the enemy overlaps our cone, that means they are in the player's sight, so we want to make them stop moving. So we're going to do something very simple of drag out of other actor, and instead of casting to the enemy AI, what we're going to do is just do actor has tag. Now this is for multiple reasons. This is just A, more efficient so you don't have to cast every single time, and B, it also means we can now use multiple enemies. So you might have 2 different enemy types, which means they'll have 2 different enemy blueprints. If you cast to one, it won't work with the other. So if you just do actor has tag and put the tag as enemy, then if we compile, save, minimize this, and open up our enemy BP here, we can select AI BP self, as that's what I've called it, but just it's basically the name of your AI and then self. Then in the top right, we want to search in the details of that, search for tags, add a tag, and just name it the same name you gave in the character blueprint, which for me was enemy. This means that this AI now has the tag of enemy, which means that it will now come up here. So if the other actor has a tag of enemy, which it does, it will do the code we're about to do, which is obviously going to disable the movement. So that again is a much more efficient way of doing it. So now again, this is a Boolean value, so we want to check if this is true or false. So we're going to hold down B, left click to get a branch with the condition going into there and connecting this into the begin overlap. False, we don't want to do anything because we don't want to disable the movement as this isn't an enemy. So true, we're then just going to type toggle movement. And you see we have toggle movement message here. This is just whatever you named the function inside of your Blueprint interface. And this is seen, so I'm going to tick is seen there. So again, that's why it makes sense for me. So if the enemy is in the cone, that means they've been seen, so I'm going to tick is seen there. Now we can right click the cone again, add event, add on component end overlap, and I'm just going to copy and paste this code. So select it, Control C, Control V, connect it all in because everything is the same, except all we do is untick is seen. So when they end the overlap, they've left our site, so we don't see them anymore, so just untick is seen. And we're going to compile, save that. Now we've got some errors, purely because I forgot to connect in the targets of the Blueprint interfaces. So this is going to toggle the movement of the targeted blueprint, but we haven't targeted the blueprint yet. So we just need to connect these into the other actor of the event overlaps as well. Compile, save, that's fixed that error. This works perfectly for us now. So now what we've got is this is going to actually disable and re-enable the movement of the enemies. So what I can actually do is I will show you what this does at the moment, because again, it will disable and re-enable the movement, but it will work through walls. So before I show you that, what I'm also going to do is select the cone, and we want to make sure that we do disable the collision. So we're going to go on collision presets and not no collision. We're going to instead go into custom, and we will have block on everything but overlap on pawn. So this is going to actually overlap the enemies, so they can overlap it, but it's not going to affect them in any way. It just means they can overlap. Then we also want to make sure we tick hidden in game, just so the player can't see it. They probably won't see it because it'll be in their vision, but they'll see a massive shadow instead, which they obviously don't want. And then we also need to go to the viewport and just scale this up. So if I scroll up, and I'm going to scale it up to, let's say, 12, as that's what I'm going to have. 12, not 21. There we go, just because I think that is a good vision sight. You might want to make it a little bit bigger if you want, but obviously just mess about with it later on. But later in the video, we are going to do a proper way of scaling this. If I hit play, you'll see that this does work. If I go over here, you'll see we're looking at them. They can't move. Look away, look again. They can't move. However, it will also work through walls. So you see I'm looking at him, but it's through a wall. He still can't move. So that's what we're going to do now, is make sure that this does scale perfectly to fit up snug against walls, so we can't look through them. So that is actually a lot simpler than you might expect. So I'm just going to scroll down under here, right click, add a custom event named check for wall. You can name this what you like, but that makes sense for me. We're checking to see if a wall is there. Or actually what I might rename it to is scale cone with wall. So it's going to scale the size of the cone to make sure it always fits with the wall so it doesn't go too far. Compile and save that. Now we're going to be doing this with a line trace. So we're going to be checking to see where the wall is via a line trace. So drag out of here, get a line trace by channel. And the start and end is going to be the same way I normally do them. So if you've seen my videos before, you probably know what's going to happen. We're going to drag in our camera, get the world location of said camera. I'm just going to drag these back a little bit like so, and straighten them up. The get world location is going to go straight into the start, but it's also going to go into a vector plus a vector, which will go into the end. So the start of our line trace is the camera's current location, and the end is just going to be forward a bit. So we'll drag out the camera again and get a forward vector, so we know we're going in the correct direction. The return value of that will go into a vector multiplied by a float, and this float is just the length of the line trace. Now this is also going to be the length of the player's vision. So I'm going to do 1200, as that is good for me again, which I did my testing earlier. You can just play about with it. How I decided it was the cone I had as 12, so I just times it by 10. Times it by 100, sorry. So I did 12 times 100 is 1200 or 1200. Now I did multiply by 10 just to make the code a lot easier and more simple later on, so I'd recommend doing that again. Sorry, I said 10, I mean 100. But yeah, just multiply it by 100, so I got 1200. Now you don't have to set the scale of the cone as well, you can just do it here. So now if I were to change this to 1300 or 1500, that will also change the scale of the cone later on. But I'm waffling on a bit now, so do times 1200 or whatever you like, connect that into the vector plus a vector, and that is now all we need to do there. The vector plus a vector is there purely just to keep this going in a straight line for us. On the line trace itself, you don't need to do anything, but just make sure ignore self is ticked. It should be by default, but just double check to make sure it is. Out of the out hit, we're going to break hit result, as we want to access a few different things. We want to access the trace start and the location, and we're going to be doing that to figure out the overall length of the line trace. Now you can use distance, however it's going to return 0 purely because of where we're starting the line trace is it's already colliding with something, which is why we have to do it manually as well. But in other circumstances, you could use distance. So what we're going to do is we're going to get location, which is basically the end point of the line trace, also in line with the collision. So if it stops before we wanted it to, that's perfect because that means a wall is there and we want that location. So this is the hit location. So we're going to do that minus another vector, with that other vector being the trace start. So what we're doing is just figuring out the distance. So we're going, the current location is hit, minus where it started, is then going to equal the length of the line trace. So to get the length from a vector, we're going to do simple vector length. It's a nice and simple one to remember there. And I'm going to right click and just straighten that up. Then again, I said I multiplied this by 100 earlier on to keep the code simple. So this vector length is just going to return 1200 if it is the full length. But if it hits a wall and it stops early, it might be 1100 or 200. So if it was the full length, it would be 1200, which means we want the cone to be the full length as well, which will be 12. So vector length divided by another float, with that one being 100. So this is now going to give us the correct scaling for our cone. So we just need to set the scale of our cone. So we can drag in our cone here and set relative scale 3D. Make sure it's relative, not world. Connect the execution into the line trace and right click onto the new scale 3D vector, split the structure pin and just connect in the float into all the X, Y and Z as we want to keep it scaling up uniformly. So we'll compile and save that. And that now is going to accurately scale the cone based upon the distance from a wall. So if we need to shorten it, it will shorten, but it will also only go up to the maximum length as this displays here. What we also need to do is make sure that we're always doing this, so we're always checking for a wall. So we're just going to hold down D, left click to get a delay at the end, with a duration of how quickly you want this to be. I'm going to put 0.05. You might want this to be a bit longer, so maybe 0.1, but 0.05 works for me. It's just obviously the quicker it does it, the more demanding it will be for your PC. And after completed, we're just going to call the custom event again, which I named scale cone with wall, like so. So this is now just looping for the entire game. We also need to make sure we hold down P and left click to get event begin play and call this at the very beginning of event begin play. So just call function scale cone with wall. We'll compile and save that. So again, this now should be the whole code working perfectly for us. So the cone is going to scale perfectly with the wall if there is a wall, and this will also work with the floor or anything. So basically it does scale where we need it to, so it can't go through walls. And whenever an enemy overlaps our cone, i.e. the player's eyesight, they're going to stop moving, and when they stop overlapping, so we can't see them anymore, they're going to start moving again. So what I've also just quickly done here is just made a code to make sure that I can see and then also not see the cone in game by toggling to. And the reason I've done that is just for the purpose of the video, so you do not need to do it. I'm just doing it so I can show you what is happening with the cone as it's scaling with the wall. But if we compile, save, minimize and hit play, we can test it out. So if we look at this enemy here, they are in our eyesight, we can see them, so they've stopped moving. Now if I were to press 2, Shift F1, you can see that we've got the shadow, which is why I obviously made sure it was hidden. If I eject, we can see the cone here. So the enemy is within this cone, as you can see there, so they can't move. If I were to repossess this, toggle it off, if I were to walk up to this wall, what's going to happen is they again walked in, so they can't move. But if I just show you again, what's happened is it started scaling with the wall. So it's not going through the wall, it's clipping slightly there just because of the angle. However, you'll see it started scaling with the wall. So I get even closer, it will continue to scale down, so it's not getting too big, as you can see there. So our eyesight is being diminished by the wall being in our way. So that works perfectly. So now again, just to prove that this does then also work with the enemies behind the wall, if I were to go up to this one over here, it's behind a wall, so it can't actually see us. So I can't see it, sorry, so it's not moving. So if I were to show you this as well, I'll get out, you'll see that our vision is not going through the wall. Then also if I were to take the wall down, our vision has now gone through the wall as it's no longer there. So we can now see the enemy, so they can't move. Obviously if I look away, we can see them again, or we can't see them, sorry, so they can now move again. So I think that'll be it for this video, as this works perfectly for how we want. What we've done is we've set up a system in which the enemy AI will stop moving whenever we look at it, and we also can't look through walls, so if they are behind a wall, as they are here, we can't see them, so they're still moving, or if I had to take the wall down, we can see them, so they'll stop moving. Works perfectly like this. Our vision scales accordingly to the wall, so we can't see through them, and then obviously when we do see the enemy AI, they stop moving, as you can see there. And again, to increase or decrease your eyesight, all you do is just increase or decrease this value here. So thanks so much for watching. I hope you enjoyed and hope you found it helpful, and if you did, make sure to like and subscribe down below. So thanks so much for watching, and I'll see you in the next one.